Hello everybody. In today's video we're going to talk about the rate of change. The rate of change is a word that you should have heard before, and it has to do with linear equations. If we look at yesterday's notes, we said that there are three basic types. There are three main types of linear equations. I'm looking at the orange part. They either have x and y on the same side, or they have y on one side, x on the other, or they'll have two y's on the left and two x's on the right. The thing that's in common to all of these is that they have a way to find the rate of change. Yesterday we called the rate of change the slope. Slope is just another word for the rate of change. Here, when we're finding the rate of change, we are finding this letter, which is slope. Slope is the same thing as the rate of change. What the rate of change is measuring is how is y changing as we go from left to right. If the y is changing, then we would show that in math using delta y. And then if we're comparing it to how we move from left to right, left and right, that's x. Left and right on a graph is how we measure x. We're going to see how the change in y, how that compares to the change in x. And we're going to compare them with division. So let's just see that in some quick examples with graphs. It wants us to find the rate of change, so we need to find the change in y over the change in x. If we're going to do that, we need 2 points. If they don't give you the 2 points, then you get to pick where you want them to be. I choose one to be up there and one to be down here. This top point is at 416. The bottom point is at 1, 4. To find the rate of change, the first thing we're going to see is how is y changing. For the y's, we started with the number 4 and then it became the number 16. What is the difference? How much was there change between 4 and 16? To figure that out, you can do it 2 ways. You can either say, how does 4 get to 16? And it's a plus 12. Or the other way you would do that is you just do 16 minus 4 and you get 12. Then we need to see, how did the x change? X was from left to right. The left number is 1. And then the right number is 4 for x. How does 1 get to 4? To get from 1 to 4, you would do a plus 3. The better math way to do that is you just do 4 minus 1, and you get 3. So we found the change in y was 12, and the change in x we're going to put on the bottom, and that was 3. If we divide these two numbers, we're going to get the answer of 4. This equation solves for the rate of change, which we abbreviate with the letter m. And like I said before, m is also used for slope because slope is the same thing as the rate of change. It's just a different name for it. Okay, so we found that the rate of change was 4. We got that m equals 4, but we also need to say, what does that mean? That's super easy to do. All we have to do is we say, well, the y's were on top. What were the units for y? The unit for y was the cost. So we're just going to say cost. $4 is the cost per ticket. 4 is the rate of change, and then the units of that is dollars per ticket. Let's do it again. We need 2 points. I pick one up here, one down here. The one on the left is at 2, 6. The one on the right is at 5, 3. You need to find, how did the y change? We need to find the change in y. How does 6 become 3? To do that, we take the number on the right, which is 3, and we're going to subtract 6 from it. Whenever you're finding how something changes, all you ever do is you start with the final number and subtract the starting number. To find change, you take the final number and subtract the starting number. If today you had $20 and yesterday you only had $5, to find the change between those, you would do $20 today minus $5 yesterday means you gained $15 over the night somehow. Maybe you lost a tooth or something. Okay, so we're going to combine the two equations. In this example, I took up a lot of space to find the change in y and the change in x. In this one, I'm going to combine the two into one step. We took the final y and subtracted the first y, and we're going to take the final x, which is 5, and we're going to subtract 2. Now we just look at the top and do 3 minus 6. We look at the top only first. 3 minus 6 is a negative 3. Then we're just going to follow the format of dividing by, and then we're going to do 5 minus 2 to get 3, positive 3. 3 fits into 3 one time, but then since we had one negative sign, our answer is going to be negative 1. We just found the rate of change is negative 1, and now we just need to describe that with the units. The y's were the games remaining, and the x is the games played. So what this means is the number of games remaining is going down by 1 every time you play a game. Alright, let's do one last example with the graphs. This one has to do with babysitting. We are earning money for every hour we worked. So that's already the rate of change is, the meaning is, we're going to earn money for every hour we worked. Now we just need to find out how much we earned. So let's make 2 points. Then we need to label those points. The second point is at 3 for x, 9 for y. The first point is at 1 for x, 3 for y. So we need to find how much did the y change to get from 3 to 9. Remember, we do that by doing the last number minus the first number, the final one minus the starting one. And then on the bottom of this fraction, we're going to put the x's. The final x, the one on the right, is the number 3, and we're going to subtract from that the starting one, which was the number 1. Okay, yes, that isn't the actual start. The actual start is at 0, but out of the ones that I labeled, the one on the left, the starting one, was 1, 3. Now we're going to simplify that. 9 minus 3 makes 6, and 3 minus 1 makes 2. So the y changed, the change in the y divided by the change in the x was, it went 6 up for every 2 it went to the right. And we reduce that fraction, we're going to get 3. So that means M equals $3. And then instead of writing all of the sentence, or instead of writing this way, we can write $3 per hour. $3 divided by the number of hours. Okay, I know that I showed something slightly different for each one of these ways, but any one of these ways is going to work for describing the rate of change and for finding the rate of change. So if you use any one of these, you'll be fine. In the next video, I'll show you how to do it with the table.